Hi, we're going to be working on Unit 4, Lesson 3 notes. These are going to be graphing rational functions. So what we're looking for is the degree of the numerator. So the degree is right up there, same, and the denominator. They're both 1 and 1. And you would go on to Desmos, and then you would find the horizontal and vertical asymptotes. I'm going to show you how to find those in just a minute. But here, the horizontal asymptote is going to be y equals 1. And then once you have it, let's go ahead and graph it. I like to do it in a different color. And then what I'm going to graph in a minute. Now your vertical asymptote, this one is going to be coming from here, okay? So it comes from the denominator. And what we're doing is we're just going to go the denominator equal to 0, and you're going to solve it for x. Here, x is equal to 2. So we're going to have a vertical asymptote at x equals 2. And we're going to have our lines going down. Okay. And then to find our intercepts. So when we do our intercepts, we're going to find our x and y intercepts. So our x-intercept is when we take our numerator, so x plus 3, and we're going to equal it to 0. And then we're going to solve it. And that is going to be our x-intercept, so negative 3, 0. So at negative 3, it's going to cross there. And to find our y-intercept, we're going to take our whole equation, and we're going to put 0 in for every x. So we're going to go 0 plus 3 over 0 minus 2. I'm going to get 3 over negative 2, which is about negative 1.5. And since we said x was 0, our y is negative 1.5. And here at 0, negative 1.5, it's going to touch about right here. All right, and then we're going to go ahead, and you can check with Desmos. I'm going to graph it, but it's going to come over here. It's going to touch those 2 points and then come down here. It's not going to touch our asymptotes, and then it will also come around here. All right. Now we're going to find, and one of the nice things is that for the horizontal asymptote, it's if these two numbers were exactly the same, we're going to take the numbers in front and divide. Now here we can see our numerator, degree of our numerator is 1. Degree of our denominator, we have 2 x's, so that's, if we multiplied it would be x squared, so it is a squared. Whenever the denominator is bigger than the numerator, we're going to have our horizontal asymptote at 0. So y equals 0, we're going to graph it right here. I'm just doing it a little bit above so we can see it. Now the vertical asymptote, remember we're going to take our denominators, set them equal to 0, so x plus 2 equals 0, and x minus 3 equals 0. I'm going to subtract the 2 on both sides, so we get negative 2, and here I'm going to add the 3 to both sides. And so I'm going to have actually 2 asymptotes at negative 2, and 3. And when you say one word and then you write it, you wanted to write down something different. Okay, so x is negative 2. We're going to have the one over here and a positive 3. And this one's a little strange looking one. Okay. Now our intercepts, Okay, we're going to plug in 0 for every x, or here, for x-intercept, sorry. We're going to take our numerator, set it equal to 0. That's easy, so we know it's going to cross at 0, 0. And this is the one that is a little bit funky. It's always going to be when it has more than two asymptotes. And the next one we're going to plug in for the y-intercept. For every x, we put in 0. And we get 0 over 0 plus 2, we know is 2. 0 minus 3 is negative 3, negative 6. And if you plug that in the calculator, you get 0, which is what we got before. Now, here you would definitely want to check on Desmos to see what it looks like. But here we're going to have 1. This is a little bit of a weird one. It goes this way. And we know this one's going to go here. This one is going to go like our cubed function, and it's going to cross that 0, 0 right there. A little bit of a strange one, but it's how it works. Okay. So again, here, our numerator is actually 0. We do not have any x's. Here we have a degree of 2, so it would be x squared. So automatically, our horizontal is going to be 0. Horizontal asymptote will be 0. Now to get the vertical, what we're going to do is we're going to take the denominator, set it equal to 0. And since it's just squared, it's going to be the same thing. So we're going to just go x plus 4 equals 0. And we subtract the 4 on both sides. It will be negative 4. So our vertical asymptote is negative 4. So 1, 2, 3, 4. All right, and then we're going to find our x-intercepts here. We don't have any x on the top, so it's not going to cross the x-axis. And so we're just going to go straight to the y-intercept. So we're going to go 1, because there's no x's there, and then we're going to go 0 plus 4 squared. It's just going to be 1 over 0 plus 4 is 4. 4 squared is 16. And that is about 0.063. So 0.116. So it would be very, very close to the 0 up there. Very, very close. And then we're going to graph it. And this is also a strange looking one. We're going to come up, and it's going to keep going up. Whoops, it doesn't have that little bump. Sorry, my hand bump. That is not a good line. Okay, so it's going to come up, and it's going to get closer. This one, it's going to come down, and it's going to touch right there and keep going. And it's going to look like that. Okay. I'm going to skip these for just a minute. I want you to go to the third page where we can find how to find all of this information on your own. So the vertical asymptote, remember, this one is going to be where x equals a number. So x equals some number means the asymptote is going straight up and down. For this one, if the degree of the numerator is larger than the denominator, you're going to find the roots of the denominator. Remember, denominator is the bottom of the fraction. And the same thing if the numerator is equal to the denominator, the vertical asymptote never changes. So find the roots of the denominator. Now, the horizontal asymptote, this is going to be y equals a number, and it's going to be going across, goes across the y-axis. When the numerator is smaller than the denominator, it's always going to be y equals 0. Now, if it's not greater than and it's equal, what you're going to do is you're going to go y equals the lead coefficient of the numerator and divided by the lead coefficient of the denominator. And that's how you're going to get your horizontal asymptote. Now, here for your x-intercepts, to find your x-intercept, you're going to set the numerator equal to 0 and solve it. Okay. And then for the y-intercept, you're going to substitute you're going to substitute 0 in for all x's and then solve it. Okay. So hopefully you get this. Remember, pause it if you need to keep writing your notes. And let's go back to our last ones. All right, so for these, again, we're going to the numerator, degree of the numerator, it's a 1 here, 1 here. So they are exactly the same. So that means we're going to find the horizontal asymptote. We're going to take the coefficient of the numerator over the coefficient of the denominator. And that 3 over 1 is just going to be 3. To find the vertical asymptote, we're going to take the denominator, x plus 4 equals 0. We're going to solve it for x, meaning we're going to subtract the 4 on both sides. So we're going to get x equals negative 4. And so let's go ahead and draw those. And negative 4. Okay, now we're going to find the x-intercepts. Remember, x-intercepts. We're going to take the numerator, and we're going to set it equal to 0, and we're going to solve it. Add 1 to both sides, and then we're going to divide, and we get 1/3. So our x-intercept is 1/3 0. So we're going to go 1/3 0, about right there, close enough. And then our y-intercept, we're going to plug in 0 for every x. So we're going to go 3 times 0 minus 1 over 0 plus 4. This one crosses out, so 3 times 0 is 0 minus 1, negative 1 over 4. And so we're going to go 0, comma, negative 1/4. So 0, and we get 1/4, so very close to it too. And then we're going to go ahead and graph them. And we're going to go, it's going to cross those and start coming down. And then it will come up here too. You can always go back and check on Desmos. Okay, so here, degree of the numerator. Whoops. As soon as I touch it, it always moves. So degree, it says squared. Here, the denominator, we have 3. So since the numerator is smaller than the denominator, the horizontal asymptote is going to be 0. And we're going to do the vertical, means we're going to set each one of those denominators equal to 0. Yep, I know. We're going to have 3 of these. That's a lot. And so we just do the opposite. We're going to add 2. We're going to subtract 1. And here we're going to subtract 3. So we're going to have x equals 2, -1, and -3. So we're going to have it here, here. I know it gets crazy, but we can do it. All right, and then we're going to find the x and y intercepts. So x-intercept, we're going to set the top equal to 0. So we have x squared minus 3x equals 0. I can see they both have x's, so I'm going to pull out an x. And then I'm going to say x is equal to 0. I'm going to break it up. And x minus 3 equals 0. Add 3 to both sides. And my intercept's going to be at 0, 0, and 3, 0. And then we're going to go the y-intercept, meaning I'm going to, for every x, I'm going to make it a 0. So 0 squared minus 3 times 0 over 0 minus 2, 0 plus 1, and 0 plus 3. Now we can see 0 squared minus 3 times 0 is going to be 0. And 0 over anything is automatically going to be 0, which is what we have up here. And if you did want to multiply it out, it would get to -6 on the bottom. So here we're crossing at 0, 0. And at, whoops, and 3, 0. All right, and then we're going to graph it. This one I would definitely put on Desmos because it is a little very strange. We've not seen any one of these before. We can see it comes down. We have our rationals, we have our quadratic, we're going to have our cubic right here, and then we're going to have our other one up here. It's really crazy. It's a really strange one. All right, and this one I'm actually going to have you guys try it on your own. Good luck. Make sure you write down all of this on that second page.